Hey guys, so I'm wondering if maybe you're wondering, well, the trinomials we talked about had the quadratic coefficient, the a term, was equal to 1. So we only really had to pay attention to factors of the constant to figure out the pairing to get the middle term. What if the quadratic coefficient doesn't equal 1? That's what I want to talk to you about today in lesson 8-6. So this is going to be, get to the right one, or no, it's lesson 8-7. Lesson 8-7. Factoring. Hello, if I could spell today. Factoring an ax squared plus bx plus c trinomial. So that trinomial, the a is not equal to 1, it equals something else. So here's the deal. I'm not going to go over the process again because the process is exactly the same. It just gets larger numbers now if we play the game and then factor by grouping. So we're going to go through a couple of examples so that you can see how things change just slightly when, oops, I forgot to put directions in here. So our directions are going to just ask us to solve. Now this should be one page. So we get 7x squared plus 29x plus 4. Now, there's always a couple ways to solve these problems. You can list out the factors and multiply them in all sorts of different ways. So I'm going to show you that, and then I'm going to show you the game. So 7 has only the factors of 1 and 7. 4 has two sets of factors, right? 2 times 2 and 4 times 1. So what I'm talking about is combining these factors. And notice everything is positive. So I'm always looking at the signs to tell me what to do. So I'm going to get a positive number here, this positive number here. So the only way that this can work is all my numbers are positive, okay? So I could take the 1 and the 7 and pair it with the 2 and the 2. So there's really, I can do 1 times 2 and 7 times 2. So that's going to give me a 2 and a 14. That only gives me, when I add them, 16. But my middle term, my linear term, is 29. So I don't think that's going to work. So then my next option would be to test out 1 and 7 and 4 and 1. So two options are 1 times 4, and then I have 7 times 1. The other option, let's see, well, let's just do this one. So you get 4, so 1 times 4, 7 times 1, and I get 7, 11. That doesn't work either. But I have a second option with that guy. I can multiply the 1 times the 1 and the 7 times the 4. And I get 1 and 28, and that does equal 29, okay? So that's that process if you want to just kind of look at the factors. And when the numbers don't have a whole lot of factors, this goes pretty quickly. But let's compare it to playing the game. So remember, we're going to take the first and the last number. This is based on the fact that you've already rewritten your polynomial or trinomial in descending degree order. So I'm going to multiply these two. That's my product number. So 28 goes here. And we've already, let me put a positive on it. And we've already identified that the sum number is the linear term. That's that positive 29. And I need to think of factors of 28 that add to give me 29. Now, for whatever reason, these are the factors that nobody remembers to think about. So how do I get 28? Well, one of them is 28 and 1. So if I add those together, I do get the 29. So for whatever reason, people like to forget those. So we have a positive 28 and a positive 1. Now, some people may have noticed a pattern when the quadratic coefficient is equal to 1. And that pattern would be that the numbers that we got in our lattice or our big X or whatever you want to call it, the 28 and the 1 in this particular case, when we were doing it before on Thursday, those numbers always ended up in the binomials. And the reason why I didn't really talk to you about that is because that doesn't work in this case. So I only like to talk about things that I know work all the time. And if you notice patterns, that's awesome. Use the pattern. If you don't notice it, I want to give you something that will always work. So remember, we split the middle term, and it doesn't really matter who comes first. And the variable has to match whatever the variable of the linear term is. And then we have an x, and then we have the plus 29. Plus 4. So that's the original. So the first term of the trinomial and the last term of the trinomial don't change. It's just we're going to split the two middle terms. So for the first two guys, 7 and goes into itself and 28, and then x squared and x have an x in common. So when I factor that, I get 7x times the quantity x plus 4. And then the next one, you're going to say, you know what, they don't have anything in common. And I'm going to say, actually, that's not true. Everything has 1 in common. Okay, so when all else fails, pull out a 1. You pull out a 1, and you get x plus 4. So our miracle has happened. And we get x plus 4 times the quantity, 7x plus 1. Okay, and that's the answer to this particular problem. So remember, the two coefficients are going to form their own binomial. Okay, now I'm not going to show this strategy that I did here, again, because I just find it time consuming, to be honest with you. You like it, go for it, okay? We've got 3x squared minus 17x plus 20. Kind of what I like about the x, I call it the lattice method, the product sum game, and then the factoring by grouping, is that the signs are all embedded in the game, so you don't really have to think about it. Whereas what I was doing here with the factors on the side for the first one with the 7 and the 4, and then trying to pair them up, I was lucky that my signs matched, but notice in this one my signs don't match. Okay, so that's where it gets starting to get a little confusing. So let's just go ahead and play the game. So the game starts off with a product, and I have 3 times 20. Now here's the one detriment to the game. When the quadratic coefficient doesn't equal 1, you get big numbers. And sometimes you have to go through a lot of factors until you find the match. If a number has a lot of set of factors, 60 is going to have a lot of factors. And then I'm going to grab the quadratic coefficient, which is negative 17. So this is when I pull out my 60 and I start listing out factors. Now, in order for them to be have a positive there, that means when positive here at the end, that means I'm looking for two factors that add to give me negative 17. So I'm not going to look at positive factors of 60. I'm going to look at two negative factors. So I have negative 1 and, sorry, that did not look right. Let's try that again. Negative 1 and negative 60. But if I add those, I get negative 61. So I know, bust, that's not going to work. Right? Boom, out. So then the next one, let's see, negative 2 and negative 30. And when I add those, I get negative 32. Okay, way off, right? So throw him out. So we got negative 3 and negative 20. That's going to give me negative 23. Ooh, we're getting closer, but not it. 4 goes in, so we have negative 4 and negative 15. Negative 19. Oh, we're getting so close. It's got to be coming. So we got negative 5 and negative 12. So I'm knowing my sets of factors because I'm using, basically in my brain, it's going through sets of divisibility rules. So 6 is even, 2 goes into it. The digits add up to 6. That means 3 goes into it. 4 goes into 60 15 times. Why? I know it. It ends in a 0, so 5 can go into it. That's what I'm talking about, okay? And I find a match. So at that point, I don't need a list anymore. Now, some of you might have gone, your brain was already clicking on it, and you're already working on it. Now, I'm going to let you into a little secret. There was a movie back, I can't even remember, 90s maybe, with Bruce Willis called, oh, what was it called? Now I just blanked on it. The Sixth Sense. So he's a psychiatrist, child psychiatrist, and he's got this, I think it's Haley Joel Austin, who is this little boy. And at one point in the movie, the little boy tells the psychiatrist, I see dead people. Okay? The way my brain works, I see numbers. So I often see the pattern or the combination that's going to work without doing any work. It just, they appear in my head. So I just, strange thing, math teacher sees numbers. Okay, so they are going to go on the sides there. Now, I'm going to go ahead and create a 4-term polynomial. Oh, and I'm trying to copy the one from before. And I'm going to keep the first term and the last term the same, but I'm going to split the middle term, and I'm going to split it using the factors from the game. So I'm going to get a negative 5x and a negative 12x. Now remember I always said try to avoid putting a negative in the front of the third term. In this case it was impossible because both the numbers were negative. So we just have to deal with that negative. Life goes on. So let's see, 3 and 5 nothing in common, but these two have an x in common. So that's going to give me x times the quantity, 3x minus 5. And then the second grouping, let's see, they have a negative in common. Let's see, 12 and 20. 4 is going to be the biggest number. So I'm going to pull it out. So again, here's my brain just going right to it because it's already calculating all the factors of 12 and 20 and trying to figure out what they have that overlaps. And let's see, negative divided by negative is a positive. 12 divided by 4 is 3. There's a 3x. Positive divided by negative is a negative, and 20 divided by 4 is 5. So, yep, my miracle occurs. And I get 3x minus 5 times the quantity x minus 4. Now remember, there's no reason for you to ever get these wrong, okay? You need to go ahead and check. Now, I'm going to tell you I've been a really bad girl right now, and here's the reason why I've been a really bad girl. I've been a really bad girl because I have broken cardinal sin number 1 when it comes to factoring, is not audibly checking for a GCMF before I begin. Now, the reason why I didn't is because I saw odd numbers and they weren't going to work on the first one. And then the second one, again, I had the odd numbers and this even number, so I knew it wasn't going to work, okay? So remember what you look for is something that all the terms have in common. So on my third one, it would be super simple. In fact, I'm going to do this problem 2 ways. Okay, I'm going to do it one way where I just launch right into the problem. And then the second way, I'm going to talk about what I should have done. Okay, so first I'm going to do is create my x. Got my product number. Let's see. Put him, and we get negative 48 goes on top. My middle term is positive 22. So in order to get a product that's negative, now we're dealing with different signs. So now I need to think of factors of negative 48 that when I subtract, or of 48 I can say, and when I subtract them I'm going to get 22, and I can play with the signs as I go along. So I'm just going to kind of do that off to the side. So I've got 48, and I've got negative, I'll just go through the list. Negative, well, let's see, bigger number is going to be positive. So negative 1, positive 48, but when I subtract, I'm going to get a 47, so no. It's even negative 2 and positive 24. When I add, I get positive 22. Hey, look at that, ladies and gentlemen. That did not take me very long to get to that answer. So I like to put my negative here to make it shout out at me, and the positive is going to go here. And then I'm going to take these guys and start with my 6x squared, end with my negative 8x, and then I'm going to split that middle term. So I'm going to put the negative first, so negative 2x, that's why I wrote them first in my lattice, plus 24, because I want to try to get x, to get this guy to be positive. So I'm going to go ahead and factor by grouping. Let's see, we've got a 6 and a 2, so 2 goes into both of those, x squared and x goes in. So I get 2x times the quantity. See, 3x minus 1, because 2x divided by itself is 1. And then next thing I'm going to do is pull out a positive, let's see, positive, and then 8 goes into both of those. Okay. And 24x divided by 8 is 3x, and 8 divided by itself is 1. So a little miracle happens. Oops, sorry about that. I get 3x minus 1 times the quantity 2x plus 8. But I'd have to tell you right now you're wrong, okay? And here's the reason why you're wrong. You are not allowed to have any binomial that has any common factors in it. So what are you talking about, Rosner? Look right here. I have a positive 2 and a positive 8 inside the same binomial. So what that says, I have to pull out a factor of 2. I have to pull out a factor of 2. Okay? So when I pull out that factor of 2, it didn't affect that 3x minus 1. What it did affect is the second binomial. And 2x divided by 2 is x, and 8 divided by 2 is 4. Now, I'm going to tell you right now, most of you would stop right there. That's the problem with factoring, my friends. You need to look at your binomials and make sure there's nothing more that you can do. Now, how should I have done this problem? I should have first noticed there is a GCMF. So the GCMF, the numbers are all even. 2 can go into all of them. So I factor out a 2. That gives me 3x squared plus 11x minus 4. I'm going to play the game with the 3x squared plus 11x minus 4. So I get a product number, and I get a negative 12. I get a sum number. That's going to be the positive 11. I need to come up with factors of 12 that are going to subtract to give me 11. So I start with 1 and 12, and I'm going to put a negative on the 1 because my number here is positive, so my bigger factor has to be matching signs with that sum number, okay? So, and there I get the 11 I needed, okay? So here's my group. So I'm going to have a negative 1 and a positive 12. So we still have that 2 outside. And now we're going to get into some brackets, because now what I'm going to do with this guy is I'm going to keep the 3x squared, I'm going to keep the negative 4, and I'm going to split the middle term into negative x and positive 12x. Oh, I don't know why this is not, I'm so used to doing that. I just need to get rid of him. And then that should actually be your brackets. Okay, and it makes more sense when I do the next bit. I'm going to factor by grouping. What do those two have? They have an x in common. So, what do I have in my answer? 2. And then I have the x. And it's going to be times, let's see, 3x squared divided by x is going to give me 3x. Negative x divided by x is going to give me negative 1. Does that look familiar? Yeah, it should. Okay. Then, in the next group, I'm going to go ahead and pull out, let's see, a positive 4 can go into both of them. Let's see, so 12x divided by 4 is 3x. See, my head's already going to the answer. And then minus 1. So, a little miracle occurs. 2 times the quantity, 3x minus 1, and then the two coefficients form their own binomial, and we get x plus 4. Exactly what we got here. Okay, so that's big forewarning on that one. Look for those GCMFs, okay? 2n squared minus n minus 1. Okay. So we're going to go ahead and play the game. We've got 2 times negative 1 is a negative 2. We're going to grab. Now this guy doesn't look like there's any number here, but remember, if you don't see the number, it's a 1. So we're going to have negative 1. So what's happening on this one, when you think about your factors, no GCMF, right, because we had 1s, is I want my bigger factor to be negative. Now I'm going to subtract still, right, because that's the only way I'm going to have one negative and one positive factor in order to get a product that's negative. So 1 times 2, oops, I wrote 2 times 1, 1 times 2. Now the bigger number is going to have to be negative this time in order to match the negative that's the middle term. So when I add those, I do get the negative 1. So I'm going to put the negative 2 first. Remember, I want to put the positive in the third spot. So we're going to go ahead and take our 2n squared and our negative 1, place them in, and then we're going to split the middle term. We have negative, oops, I like x's so much I can't help myself, negative 2n minus n. And then we're going to go ahead and factor by grouping. So interestingly enough, this has a 2 and an n in common. So that gives me 2n times the quantity n minus 1. Oh, that's supposed to be a plus over there. Sorry. That's a plus. And then for these two, I'm going to pull out a positive 1. Remember, if you can't find anything else, they always have 1 in common. And that gives me n minus 1. Awesome. So the miracle occurs. And my answer is the quantity n minus 1 times the quantity 2n plus 1. Okay? I'm going to do one more. And basically when I did my notes, I only did 1 page, but you know the drill. My screen is in landscape, not portrait, and that's why I run out of room. So we've got 4x squared minus 3x plus 5. Okay? So go ahead and play the game. And I'm going to multiply these two. And I get 4 times 5 is a positive 20. And I'm going to grab the linear coefficient, negative 3. So this one is a real conundrum. I like that word. And here's why it's a conundrum. I need to come up with two factors that multiply to give me 20. Positive 20, mind you. And because it's positive, it would need to add to give me negative 3. So 1 and 20 add to give me 21. 2 and 10 add to give me 12. 3 doesn't work. 4 and 5 give me 9. Those are the only factors that multiply to give me 20. So there isn't a possible way to put these together. This didn't work, this didn't work, this didn't work, and there's nothing else to try. So this is what we call a prime polynomial. Notice there was no GCMF. We had a 4, 3, 5. Boom, done. Can't do anything with that. So this is a prime polynomial. And that's a polynomial that cannot be written as the product of two polynomials, usually binomials, but not necessarily, with, and here's the killer kicker, integer values. Now, you may learn in later math classes that, yeah, I could actually figure out what those would be, but they would contain radicals. So that's not going to work for us. Okay? And before we leave, I want to go over vocab one more time. You heard me use it throughout this lesson, but I just need to make sure that we all are on the same page. So what we've been talking about are quadratic equations. And we've been talking about them for a couple of lessons now. So it's a trinomial written in the form ax squared plus bx plus c equals 0. So notice when it's an equation, you got to involve an equal sign. Okay, so this means we took our polynomial, everything on the left, the 0 on the right. We did solving by factoring before, so this is how we would have to set up. But again, I'm just looking at vocab right now. So the first guy with the degree 2, so this overall trinomial is a degree 2. That's the highest degree that shows up in this. This guy is called the quadratic term. He's the guy that makes us get a parabola, okay, when we graph this. Okay, so now A has a name of quadratic coefficient. We talked about this before, but I just want to make sure we get it down again, okay? Now, the guy in the middle who has just the x, this guy is, remember, called a linear term, because when you had like y equals 2x plus 3, we got a line. So this is a linear term, which makes b the linear coefficient. And last, but certainly not least, is our good friend, the constant. Okay? So he's the constant. And generally speaking, even if he has a secondary variable, like we have x's and y's in our equation, we still kind of refer to him as the constant. But normally what this is just a number without a value. As you've seen in all the examples we've done today, the last term was always just a number. Okay? All right, so there you go. There you go. Good luck, and we'll talk about this on Tuesday. Sorry, that was my elbow cracking. Bye.